Hello guys. This is me again. My name is Joseph AGK OG. Our topic of discussion tonight is what we call the mean, variance, and standard deviation of a binomial probability distribution. This will be our last lecture on this topic of binomial distribution. So that the coming weeks we'll be covering other topics in statistics. So let's begin. Right, let me share my screen so you can see what I'm talking about here. Okay. Now I hope you can see my screen. You can start. The mean, variance, and standard deviation of a binomial or binomial probabilities. I will change it to binomial distribution. Binomial distribution. Okay. Distribution. Yeah. Now the formula is this. For the mean, we use the symbol mu, n times p. And for the variance, which we use the symbol delta square, is n times p times q. And for the standard deviation, we use it as always. The standard deviation is always the square root of the variance, where n is the number of trials, p is the probability of success, and q is the probability of failure, which we always get by doing 1 minus p. Now, I've explained all these concepts at the beginning of my topic on binomial distribution. So for more information on what p, n, p, and q actually represent, you can always visit my lecture, my video, my channel, and YouTube, and watch my previous lectures that covered binomial probabilities. Okay, now let's apply these formulas. Now, the first question says to find the mean, variance, and standard deviation of the values for the values n and p. Now, remember, I'm sure that you have all done mean, variance, and standard deviation for the frequency distribution. But now we're doing the same thing, but we're doing it for a probability distribution that we call binomial. Now, in this case, you say n is 90 and p is 0.75. That means the probability of success. Before we can find the mean, the variance, and the standard deviation, we need to find the q part. And we always get that by doing 1 minus p. So 1 minus p, where p is 0.75, will give us 0.25. Let me show you how this is done in a calculator. I'm going to share my screen so you can see a new screen here. I'm going to use an online scientific calculator that is free. Anybody can get it. It's called desmos.com/scientific. When you type this scientific, it will give you a free scientific calculator that is available online. You can see right here. So we are trying to do 1 minus 0.75. That gives us 1 minus 0.75. That gives us the answer right away. You can see the answer right here, 0.25. So that is how we get our Q. And you can see it in my PowerPoint right here, 0.25. Now with this, we are ready to find the mean, variance, and standard deviation for this question. You can see right here, we have the mean is n times p, which is 90 times 0.75, which gives you 67.5. I can show you this in the screen with my calculator. We have 90 times 0.75. You can see, I'm going to clear it. Now, 90 times 0.75. Give me the answer right here, 67.5, which is the same thing as what I have in my PowerPoint. You can see it right here. See the 7.5. And then standard deviation, sorry, the variance will be square will be n times p times q. Our n is 90, our p is 0.75, and our q, we got it from the previous slide as q equals 0.25. So when we plug this in into this formula right here, we have 90 times 0.75 times 0.25. So let me show you on my calculator. I have here. So I'm going to clear it. So 90 times 0.75, okay, times excuse me, let me clear. Let me begin with my mouse. My hammer is having issue with my mouse. So you have 90 times 0.75 times 0.25. That gives me 16.875. You can see it right here in my PowerPoint. I do the same calculation. I say 90 times 16.8. If you round it up, you give us 16.88. Now, the standard deviation is always the square root of the variance, which is the square root of 16.88. That'll give us 4.11. I can show you on the screen here in my calculator. I have the square root of 16.88. Okay. The square root of 16.88, 4.10, which 108, which you can round up to 4.11 or 4.1, depending on the number of decimal places that you are asked to use. Okay. I hope you're enjoying it. Now, I believe that theory is practice. Let us see how we can apply this to real life situation. Okay. Now, let's do one example. It says here, the statistical bulletin published by the Metropolitan Life Insurance Company reported that 2% of all American bets result in twins. If a random sample of 8,000 bets is taken, find the mean, variance, and standard deviation of the number of bets that will result in twins. So how do we do this? Well, first of all, let's figure out if it is binomial. Now, it said 2% of bets result in twins. That means the outcome is two outcomes. Either they are twins or they are not twins. So that is binomial. And also, N is 8,000 bets, and they are selected at random. That means they are independent. Okay. And our P is 2%, which is 0.0. So we have it listed here. N is 8,000 bets, P is 2%. When we change it to decimal, it becomes 0.02. And to get our Q, we do 1 minus P, which is 1 minus 0.02, give us 0.98. We're ready to calculate the mean. Mean is N times P, which is 8,000 times 0.02. I can show you this in my using Desmos. 8,000. So when I have 8,000 bets, 8,000 people that were chosen, actually, I use 80,000. 8,000 times, my mouse have issues, okay, 0.02, I give it 160 bets. So that is exactly what we have on my PowerPoint. See, 160 bets. So this means that on average, 160 bets result to into twins, or will be twins. Now variance will be n times p times square, which means 8,000 times 0.02 times 0.98 will give us this. And then the standard deviation is the square root of variance, which means the square root of 156.80. And that gives us if I can share it, 156.80. The square root of 156.80, give me 12.52 approximately. 12.52 approximately, which is what I have in the PowerPoint. Now, this is how we get the mean, variance, and standard deviation for binomial probability distribution. Now, in my subsequent lecture, or in my next lectures, I'll introduce a new topic, because I believe I have covered a lot of topics under this under binomial distribution. Thank you for watching and listening, and I will see you next week. Have a good day.